I think machines and humans are different. In some specific tasks like computer vision, they are not smart as humans. So, for example, it's not hard for humans to distinguish the cats and dogs after seeing 10 images of the cats and 10 images of the dogs. But machine learning models need a rather large training size, which means that they need hundreds of the dog images and hundreds of the cat images, and then they can learn some patterns from this training set and detect the cats and dogs correctly.
Yes, it's true that you can teach a person to solve some tasks with only a few examples. But for most of the machine learning models, they need to be trained on a large number of examples in order to have some good performances on the tasks. And also, a person is capable of understanding the task very quickly. But usually the training process for the machine learning models can be really computationally intensive, given that they need to be trained on a large number of examples.
It depends on what type of the data it is. So if the data is noise data, more data will reduce the performance of the model. But if the data is useful, is relevant, and introducing more features, in that case, it will help to improve the model.
It is not true that more data is equal to better results. The first reason, more data does not mean they're quality data. So if more data is biased or tarnished in some sense, that means your results will be bad in some sense. For example, they could be biased in terms of some racial or gender groups, and will raise some fairness concerns. And the second reason is that if the model that we're using is too simple to explain the complexity underneath the data, then adding more data will not change the simplicity nature of the model and will not improve the results a lot. And also, not to mention that adding more data will increase the data storage cost and also some training costs. The machine learning algorithms themselves do not have the capabilities of dealing with messy data. For example, invalid entries, missing values, data sparsity, etc. And those messy data issues should be addressed during the data processing step, which is extremely important before the modeling step.
As far as I know, machine learning model can't handle the messy data very well currently. So especially in industry, the big techs, they have data engineers to pre-process the data and then feed the pre-processed data to train the model.
It is true that some of the jobs might be replaced by AI techniques. For example, some manufacturing workers might be replaced by robots that can function more efficiently and might be easier to manage. But that does not mean the human beings are redundant. In most of the cases, the AI techniques will complement and facilitate us in doing better in our jobs. For example, the GPS techniques help the Uber drivers navigate and find the fastest route. The computer vision techniques help the doctors analyze the CT images. The recidivism prediction models assist the judges in making some pre-trial decisions. So, and also we as human beings will still need to monitor, maintain, and improve those techniques in order for them to function longer and better. So we are not redundant in that sense.
I don't think AI will replace a human, because it is a human who creates the AI, who make the AI intelligent. We humans have emotions, have creative thinking and critical thinking. But I think AI and the human can benefit each other. For example, the AlphaGo and AlphaZero can beat humans very easily when playing the game of Go. We can learn a lot of the playing strategy from them. But after learn more from them, we can propose new models to make AlphaGo smarter.